Hey, hi, everybody. This is my longer video for my final project for the big data analytics class. My topic was on Internet of Things, and um, I went to create a pseudo app that someone could use that focuses on kind of a health focused app, which is why I titled it Calm Coach. It's helping people reduce their heart rate so they can live healthier lives. So just going over terminology, Internet of Things. This was, again, the topic that I signed up for. I had heard this term a lot, but I didn't know exactly what it was about. So I'm just providing a definition here. This is from Oracle, the quote at the bottom. But basically it talks about the Internet of Things is kind of like a network of all these different kind of smart devices that exist nowadays that create a lot of data. But we can also connect these things, hence the word internet. So we can kind of create a network of all these different smart devices and their sensors so they can work with each other and talk with each other. For instance, like Alexa, when you ask Alexa to turn on, like lower the lights in your living room, that's Internet of Things at work, where that has access to, the Alexa device has access to the sensors with your light switches, so they're able to lower. But there are tons of other examples of smart devices and sensors that you can use. What I focused on specifically in my project was a Fitbit device, specifically like a Fitbit watch that you can wear that monitors activity levels, health data, gives you a lot of different information, not just about steps, which is what people often talk about, but gives you heart rate information, gives you sleep information, with a whole bunch of other things. So I wanted to use Fitbit data. And my goal was to kind of create an add-on application app that someone could, a user of Fitbit could use to improve their health, where it could give weekly feedback to that user on how to lower their resting heart rate. So again, resting heart rate is often associated with better health outcomes. So the goal here being to help people lower it through weekly feedback. Again, as I mentioned before, Fitbits provide a lot of data. I only used a couple different streams in this project. So they were kind of daily summary streams. You can also collect intraday data from Fitbit, but you need special permission, which in my documentation I outline. I did apply for that permission and I received it. I just ended up not using intraday data for activity like heart rate levels or sleep or anything like that. But if you're interested in that sort of thing, you can access it. You just need to apply for permission. But for my project, I focused on daily summary data related to health or heart rate and activity levels, as well as sleep summary data. So as we'll see, that gives you information about sleep cycles, length of sleep cycles, amount of sleep cycles throughout the night. So deep sleep, REM sleep, light sleep, all that, and kind of how it flows, as well as when you went to sleep, when you woke up. So a lot of information there. Now the actual analysis component, I used kind of a two-phased analysis method where first, I used tree-based modeling to kind of create a general profile of each user or of a user. So I used a test case with a single user's data, but this could be scaled to more than one user. So the first phase is creating a tree-based model that is based on aggregate weekly level data to kind of create a profile of how heart and activity data and sleep information relates to resting heart rate. And then after that, I did a second phase of linear regression modeling that initially focused on the differences between those weekly aggregated predictions and the daily observed data. So identified specific weeks that I wanted to understand, well, what made those so special? So my project consisted of working with an API, working directly with a web API. That was a big part of what I did. And as well as formatting the data and working with the data that came from an API. I also, as mentioned before, I did use some machine learning modeling. So I used Spark's MLlib package to do that and ultimately providing health guidance and feedback based on that analysis. I just want to emphasize those first two components because up to this point in the class, we've kind of been working with, data sets that we just get that are nicely, neatly formatted and all that. Whereas with Internet of Things, chances are if you're going to work with Internet of Things, you're probably going to have to work with a web API. So my project kind of outlines all the steps in the learning process that I had to go through to understand how to work with an API. A lot of learning went into that, and I'll get into that. But hopefully that'll provide guidance for other people if they're interested. Also, formatting the data. These were not, the data that I received from the API was not neatly formatted. It was very messy JSONs, a lot of nested structures, inconsistent structures across data streams, so required a lot of formatting. So I kind of walked through those steps as well, so helpful guidance for others. Now let's get into the actual work that I did. So first step was connecting with the API. What this involves, so I kind of listed some major learning experiences here. So this involved working with HTTP and JavaScript, at least at the initial stage. That was just the beginning, and then I moved fully into PySpark and Python. I never worked with those really before, so I learned I had to kind of fumble through it. And also dealing with less than ideal documentation. When you're working with these kind of web APIs, they're just not used as much as something like PySpark or that sort of thing. So you're kind of limited in the documentation that's both available directly from the API as well as potential outside resources. Like we all use Stack Overflow or Google certain things to try to find out solutions. When you try to Google issues that you're having with these web APIs, there's a lot less material out there. So you're more or less on your own compared with other, like when you're just doing homework assignments with PySpark. Another thing that I had to deal with APIs is authorizations, permissions for things. So I worked with live data, data that was streaming directly from a user. So you have to work with, gaining authorization for your app or your code to access this information. So gaining authorization from the user themselves, and there's an extensive kind of authentication process that you have to go through, and codes you kind of have to use multiple stages to get the codes, and they also expire. Once you get your authentication codes, they don't work for perpetuity. They have an expiration. For me, it was 8 hours. So I had to create a system that was able to update those as needed. So if I need to pull information, it would update. So working with that was a big learning experience. And then finally, oftentimes when you're working with web APIs, they will limit how much data you can actually pull because they don't want to overload their system from people pinging it all the time and with massive requests. So they put a limit on the amount of data that you can pull. So you kind of have to work around that and create loops and iterative functions to work within those limits. All of that stuff is shown within my other materials. I'm not going to go into it extensively in this, but it's there for people if they want to look. Formatting data from an API, again, I mentioned very complex data structures. Schemas were extremely important. I realized this kind of towards the end where I was coming up with very strange results and my code was taking forever to run, and I realized that there were some issues with schemas. So not only creating schemas from the beginning, but also keeping those consistent throughout. So if you're saving files to try to shortcut some of your pre-processing, just know that when you load them back in, you're gonna have to reload a schema along with it. But yeah, trying to figure out how to create schemas for complex data structures. And also I did a lot of working with time functions because with Internet of Things, a lot of this is time-based data. So I became very well acquainted with all the various time functions in Spark, and I use them extensively to aggregate as well as create split points and all that. And then finally, dealing with missing data is something that you're going to have to deal with anyways with real life data. So now that I've gotten through all those kind of crucial points that were essential for me to actually work with an API and critical knowledge that I gained from that. Now I'm going to get into the actual analysis that I did. So this is the part of the code that you can run by yourselves if you want. The data that I use is available. All the other stuff with the API, working with the API, the code is there, but you can't run those functions because it's based off of the authorization that my developer account had. And I'm deactivating that because I don't want people to pull data in my name. I'm liable for any information that's kind of pulled through that account, as well as my friend who gave me access to their data. I don't want other people to just kind of be able to access all their data. So those functions don't work. The code is there, and all the steps that I did to do all that stuff, working with HTTP and JavaScript code, is all in my code as examples, as well as all the Python stuff to do all the pull requests is all in there for your guidance. But now we move on to the analysis. So my outcome variable was resting heart rate. And I have all my features listed here. So I have kind of features related to heart and activity levels. So those are kind of minutes spent and calories burned in different heart rate ranges, as well as a bunch of sleep features. So when you go to sleep, when you wake up, the amount of time and number of cycles in different sleep cycles, all that was used. The way I analyze things, so again, this had a multi-stage structure. So stage one was modeling relationships with weekly aggregated data. I used a tree-based algorithm, a gradient boosted tree. And next stage was modeling daily level relationships from I focused on the most recent week of data, as well as the week with the lowest average resting heart rate. I used linear models there. And the focus with that was to try to predict differences between the weekly predicted resting heart rate, which I got from stage one, and the daily observed resting heart rate. And then I took that information and I was able to compare the influence of the different variables during their best week versus the influence of those variables during the most recent week. So then I could provide feedback for the upcoming week. So this is kind of meant to run every week where you can give a user feedback for how they can change some of their lifestyle and habits to help lower their heart rate. Overall, my kind of learning experiences from the analysis. So keeping track of all my various data frames was very difficult at times. I did a lot of data wrangling to move things around and aggregating and having to do things in various sequences. So like scaling, creating feature vectors and re-aggregating and all that. So kind of keeping track of all that was difficult and got me frustrated at times, but you can get through it. Another thing, as I mentioned before, if you are, if you save data that you've pre-processed to kind of shortcut that process, so you can load it up later without having to go through all those pre-processing steps, be sure to properly set up your schemas when you load those back in, or else it will just wreak havoc on your system. I had some issues with memory and I kind of I ended up kind of fixing them because I was able to, once I switched the schemas back, instead of treating every number as a string, which just made my models take forever, it fixed a lot of that. So really emphasis on schemas. And also managing the various limitations of the machine learning methods and kind of getting creative to try to achieve what I wanted to with my project and my app. I do want to note that I am aware that there are some flaws with my modeling methods, but I was more focusing on using these technologies and working with an API, so less on the modeling methods. And then finally, setting up a pipeline that can account for more than a single user's data. I used a test case user, but yeah, kind of creating a system that can work with a lot of different users.